Today, we are diving into some absolutely fascinating research about an AI that didn't just learn from its human teachers, it completely, and I mean completely surpassed them. So let's just start with a wild question. Think about this. We rely on the internet for literally everything, right? But what if the system running it all, the one keeping everything online, was actually smarter than the brilliant engineers who built it in the first place? All right, to understand how an AI could even pull this off, we first need to take a trip to the place where the internet is managed. It's called the Network Operations Center, or the NOC. I want you to picture an air traffic control tower, but for data. That's a NOC. You've got teams of people staring at these screens, watching a constant storm of information, performance metrics, alarms, user reports, all to keep the network running smoothly. When something goes wrong, they have to sift through all that chaos and make the right call, and they have to do it fast. But here's the catch. Today's networks are becoming absolute monsters. They're just too big and too complex. The old way of doing things, relying on a handful of human experts, is starting to break down. It's slow, it's expensive, and honestly, it's becoming less of a science and more of an art form based on gut feelings. And the stakes? Oh, they are unbelievably high. For almost half of all major businesses, just 1 hour of server downtime can cost over $1 million. Can you imagine that pressure to never, ever make a mistake? So this is where AI enters the picture. The researchers decided to start small. They built an AI assistant, kind of like an apprentice, to see if it could just learn from the human experts and maybe help automate a few things. And what's so cool about this slide is what happened next. Take a look at this chart. The red line, that's the performance of the rules designed by the human experts. The blue line, that's the AI apprentice. And as you can see, they are practically identical. The AI learned to perfectly mimic the collective wisdom of the entire team. So the big takeaway from this first experiment was huge. It was proof, yes, an AI could be trained to handle these decisions. It could learn the rules, make the same calls as the pros, and get the same results. A massive success. But it was really just the beginning. Because that success led to a much, much bigger question. What if an AI could do more than just copy its teachers? What if it could actually become better than the very experts it learned from? And that brings us to this key idea, superintelligence. Now, we're not talking about science fiction here, not Skynet. In this context, it's a very practical, measurable goal. It just means an AI that consistently makes better decisions and gets better results than the rules designed by humans. Simple as that. You've seen this happen in games, right? AIs have learned to absolutely dominate the world's best human players in chess and Go. And they did it by finding these wild strategies humans had never even thought of. So the researchers wondered, could we take that same magic out of the game world and unleash it on the messy, high-stakes reality of network management? To make that leap to go from just copying to true mastery, they needed a whole new way to train their AI. And they found it in one of the most powerful techniques in modern AI. Let's talk about reinforcement learning, or RL. The absolute easiest way to think about it is like training a puppy. Seriously, you give a command, it does the right thing, it gets a treat, a positive reward. Over and over again, it learns which actions get it the most treats. RL lets an AI do the exact same thing. It learns by trial and error, discovering brand new winning strategies all by itself. Now, obviously, you can't just let an AI learn by trial and error on a live multi-million-dollar network. That would be a complete disaster, not to mention incredibly slow. So the team built 3 custom training environments. The most important one was a super fast simulator that could zip through thousands of hours of training in just a few minutes. A total game changer. This let them create this brilliant 3-step training process. First, they trained the AI in that fast, safe simulator. Think of it like a flight simulator. Then, they deployed that trained AI into the real system, but with its ability to explore turned off, kind of like putting it on a leash. And finally, step 3, they carefully, prudently let it start exploring new actions on its own, letting it improve itself in the real world. And this, right here, is where things get really exciting. After all that careful training, it was time for the moment of truth. Could this AI actually do it? Could it achieve superintelligence? And this chart says it all. Just look at this. That red line is the human experts, same as before. The green line, that's the new reinforcement learning AI. The second they switched it on, it was already performing better than the experts. And it didn't stop there. It kept learning, kept improving, and its performance just shot past that human baseline. It wasn't even close. So you're probably wondering, how did it do it? Well, the AI discovered its own set of winning strategies that were totally non-obvious to people. For example, it learned to just cram traffic onto the single, cheapest, most efficient path, something humans thought was too risky. It learned to just ignore tiny, temporary problems that would fix themselves anyway. And it learned to prioritize fixing any issue on links that were shared across multiple routes. And the researchers really hit on this point. A human operator would look at packing all the traffic on one path and think, no way, that's too risky, you'll cause a traffic jam. But as it turns out, that human intuition in a system this complex was just plain wrong. So this incredible breakthrough is way more than just a cool experiment. It is a huge step towards a revolutionary new way our entire digital world could work. The ultimate vision here is to create autonomous, self-driving networks. I want you to imagine a network that can predict problems before they even happen and fix them automatically without a single human having to lift a finger. This could lead to a more reliable, more efficient, and way cheaper internet for every single one of us. And this kind of technology isn't just for managing internet traffic. This proves that AI can learn to optimize these massive, complex, real-world systems in ways that are better than human experts. So that leaves us with one final fascinating question to think about. What other huge, real-world problem should we unleash this kind of super intelligent AI on next?